Hello, so this video is to teach you about pensions. So here's a quick schematic. We'll look at it again after we've gone through an example. Okay, so during a worker's working life, they can make payments to build towards a pension where you receive payments after you retire. Okay, so payments in are like savings. They will gain interest. So for payments in, we use the compound interest formula. And their value will build over time. Okay, so there will be many of those. We'll just look here. The last payment in the example we're going to look at, will be, if their monthly repayments, would be 1 month before retirement. Okay, and all of these values will add up to a fund, okay, a total fund which will be used to pay out the pension amounts in retirement. Okay, so everything in blue is before retirement. They are payments into a scheme or a bank, and they will gain interest with time. So we use the compound interest formula. Then, upon the point of retirement, the first payout will be at the beginning of the first month of retirement. Okay, so just to note there, we count that as time 0. Okay, and this is money out, so we treat it like a loan. You're receiving payments, all right, and for money out, we use present value, the present value formula. Okay, and we want the amount that received to be the same for each payment, so we're using present value, and they're all shown in red here. Okay, and notice that the last payment out will be, for example, 1 month before the scheme ends, so we use this factor of t minus 1. You'll see that in the example coming. But when you add all of these payments, okay, they should add up to the same value as the total fund that was built up in savings. Okay, so the total fund should be equal to all of these monies paid in, and also equal to all the monies paid out. So okay, this example, so we'll see that in action question issued in 2014 by Department of Education when they were rolling out the new Project Maths curriculum. Okay, and it is commonly known as Padraig's pension, and it is very well known with maths classes. Okay, Padraig is 25 years old and is planning for his pension. He intends to retire in 40 years' time when he is 65. First, he calculates how much he wants to have in his pension fund when he retires, and then he calculates how much he needs to invest in order to achieve this. He assumes, in the long run, money can be invested at an inflation-adjusted annual rate of 3%. Your answers throughout this question should therefore be based on a 3% annual growth rate. Okay, so Padraig is a very well thought out 25-year-old. Okay, let's see. Part A says write down the present value of a future payment of €20,000 in 1 year time. So this is really not relevant to the information above. It's just a general starter question. We may use it later on in the question because they tend to lead us in. Okay, so we know about present values. Let's write down the present value formula. And let's insert the information that we have. The future payment is €20,000. That's F in 1 year's time. That is time as 1, T, and we'll use 3% as I. Okay, so P is equal to 20,000 all over, and we can add it right now if we want 1.03. So that's our 1 plus the 3%, 1.03, and in 1 year. Okay, so dividing 20,000 by 1.03, we get an answer of 19,417 and 48 cents. So check that with your calculator that you can arrive at the same answer. Part B, write down in terms of T the present value of a future payment of 20,000 euro in T years time. So this is very similar but more general. So in terms of T means that T should appear in the expression you give for your answer. We've got the same future payment, same F. T is just T in this example, and our I will be the same 3%. So it's a much more general question. We still have 20,000 and we still have 3%, but we're writing a general expression for any length of time T where you can enter different values of T. Okay, so I get the feeling their setting is up for the question that is to come. Okay, part C. Padraig wants to have a fund that could, from the date of his retirement, give him a payment of 20,000 euro at the start of each year for 25 years. Show how the sum of a geometric series can be used to calculate the value on the date of retirement of the fund required. Okay, so what do we have in there? So here's our payments. Okay, there are F's. We want 25 years worth of them. Okay, so I'm thinking N will be 25. Okay, it'll be 25 of them. We're talking about the sum of a geometric series, so we have to show how that's going to be used. So SN formula to calculate the value of the date of retirement of the fund required. Okay, so if we're going to use the geometric series sum formula, well then let's write down a geometric series. Okay, so and recall parts A and B might be helpful. Okay, so on the point of retirement, okay, when they just retire, the first term, the first payment out will be 20,000. Okay, and the second payment will be the present value of 20,000. Okay, so after 1 year. Okay, 1.03 to the power of 1. And you can see where this is going. T3 will be at the start of the third year, so actually it's at the end of the second year. That would be 2, sorry. And so on. And the last payment, the 25th payment, will be at the start of the 25th year, or it will have had 24 years to adjust, okay, its value. All right, so a few points to note there. The first payment is just 20,000. It's before the time the clock has started ticking. Okay, the second payment needs to be adjusted by 1 year for its present value, the third one by 2 years, and the 25th one by 24 years. So the power used is 1 less than n. Okay, so I can see a pattern there. We just need to add them all up. Okay, we're going to be getting the sum of 25 terms. Now let's first factorize. Let's take out the 20,000 to simplify things, and we get 1 plus 1 over 1.03 plus 1 over 1.03 squared, the whole way up to 1 over 1.03 to the power of 24. Okay, let's examine the pattern in the square brackets. A is 1 and R is 1 over 1.03. Okay, and we have 25 terms. Okay, so n is 25. So we can use our calculator to do all the work. We'll multiply by the 20,000 at the end. Quick reminder, the SN formula is A by 1 minus R to the power of N over 1 minus R. Okay, that's available in your formula and tables books, and now let's fill in the formula. So 1 times, which won't alter anything, 1 minus 1 over 1.03 to the power of 25, all divided by 1 minus 1 over 1.03. Now let your calculator do all the work, make the best use of the fraction button as possible. Okay, we have 20,000 multiplied by 17.9355412. Okay, so use as many digits as you can for now, and when you do that multiplication we get a total of, rounding to cent as we have money, 358, so 358,710 euros and 84 cents. Okay, so use your calculator, see can you get the same answer as that. So that will be the total fund required to be in the saving scheme or the pension scheme upon the point of retirement. Okay, so that's part C. Part D then, okay, we're going to start focusing on what he has to save to achieve that. Padraig plans to invest a fixed amount of money every month in order to generate the fund calculated in Part C. His retirement is 40 years away, so that's 40 times 12 or 480 months away. Okay. Find correct to 4 significant figures the rate of interest per month that would, if paid and compounded monthly, be equivalent to an effective annual rate of 3%. So that's our first task. His payments are not yearly, they're going to be monthly. Okay, and the annual rate is 3%. So what does that 3% mean? It means that €1 becomes €1.03 after 1 year or 12 months. Okay, so it's earning compound interest, so let's use the compound interest formula. Let's start over here. F is equal to P by 1 plus I to the power of T. Okay, let's use our fictional amounts of €1, which will be P, what's invested, and €1.03, which will be F, what's the final outcome. Okay, so entering those numbers, 1.03 equals 1 times 1 plus I, so we don't know I, we're trying to find that I, the monthly equivalent rate, and our time will be 12 months. So you're using the annual final figure and we're trying to go backwards and find the monthly interest rate. So we can divide both sides by 1 just to make it look a little simpler, and we get 1 plus I to the power of 12. Now to isolate that bracket, to just have that bracket 1 plus I, we can get what's known as the 12th root of both sides. Will give me just 1 plus I, so that's getting the 12th root of both sides. Indeed, you don't need those brackets there at all. Okay, and to solve for I, we'll take 1 from both sides, and the next line would look like this. 1.03, its 12th root, subtract 1 will give me I. So you can do that on the calculator. Now, my calculator returned to me this figure, 2.466269722 by 10 to the power of minus 3. Okay, what's that now? So it's using standard notation. By 10 to the minus 3 means that number has been divided by 1,000. So if you wanted to see it in a more familiar way, dividing by 1,000 will have moved the decimal point 3 points to the right. So let's undo that. 1, 2, 3 points here and fill them in with zeros. So the same number would be 0.002466, etc. All of that. I'll add in a few more digits just for now. So with 269, okay, equals I. All right. Now, if I revisit the question, it says correct to 4 significant figures. Okay. Now, the word significant means important. What are the 4 most important figures in this big long number that indicate the size of I? Okay, and they are 1, 2, 3, 4. Those 4. So I can say that I is equal to 0.002466. That's in decimal form, or multiplying by 100 will give us a percentage, and we get 0.2466%. So it's a much smaller percentage for monthly. All right. So we need that if we're to be using monthly repayments. Now, D part 2 asks to write down in terms of N and P the value on the retirement date of a payment of P euros made N months before retirement. Okay, so the wording here is a bit tricky. So before the retirement date. Okay, so N months means it spent N months in the bank earning interest. Okay, so again, it's earning interest, so we're dealing with the compound interest formula. All right. We're using fictional amounts, so amounts we don't know, so P. All right. We now know the monthly interest rate, 1 point, when we add it in here, 0.002466, and if it spends N months in the bank before the retirement date, it will earn N months worth of interest. Okay, so that's the answer to that part, and I have a feeling we'll use that going forward. Okay, so part 3 of D. If Padraig makes 480 equal monthly repayments of P euros from now until his retirement, what value of P will give the fund he requires? Now let's remember from part C, the fund he requires is 358,710 euros and 84 cents. Okay, and recall the part we've just finished. Okay, the worth of the payment. So the payments will be, so the very first one will be P multiplied by 1.002466, and that very first payment will spend 480 months in the bank earning interest. The second payment will spend 479 months earning interest, and so on, up until 1 month before retirement. The last payment will spend only 1 month in the scheme earning interest. And when you add all those little, or not so little, payments together, we should get the same total that we require for the fund, the 358,710 euro and 84 cents. Okay, so doesn't look pretty, all the decimals, but we can work with this now. So we're going to use again our geometric sum to add up the individual payments. Firstly, however, I'm going to factorize, take P out as a common factor, and I'm also going to, just for familiarity, I'm going to reverse the payments. So the one with the power of 1 is going to come first. Okay, plus the second to last payment would spend 2 months in the bank earning interest, and so on till the very first payment would spend 480 months in the bank earning interest. Whoops, 84. All right, we good to go. All right, so let's look at our geometric series. We can see here that A is 1.002466, R is the same, 1.002466, N is 480, and what else do we need there? Our formula. I'll write this up at the side to save space. A by 1 minus R to the power of N over 1 minus R. Okay, from your formula books. Okay, so P will be multiplied by all of this. So we're going to get the sum S480. So A by 1 minus R to the power of 480 divided by 1 minus 1.002466. That's our R. Now again, let your calculator do the work. Now that should be equal to that total again. Alright, letting the calculator do the work, we get a figure there of 919.3810.223. Should be equal to 35871 and 84. Okay, so solving for P, we divide and for P we get 390.165, rounding to the nearest cent because it is money, €390.17. So that's his monthly repayment to get the fund that he needs. Okay, again, all the decimals and the powers are not so pleasant. Take your time, write notes on your page if you need to, practice with your calculator. Alright, so moving onwards, we're going to just recap on that slide that we had initially again. Okay, so now it will make more sense. Okay, so for his working life, Padraig was making repayments, 480 repayments, and each of them was gaining interest while sitting in the bank. The very last payment was 1 month before retirement and gained 1 month interest. When we got SN or S480 of those, so they're monthly, okay, we got our total fund, which was the 3,508, 7, 10 and 84. Okay, what else is of note there? So these were monthly, okay, and because we're monthly, you need to calculate the monthly interest rate before we started. Okay, the payments out, that should read 20,000, not 2,000. Okay, payments out started then, and we used present values. Okay, so this was compound interest, and this is present values. Okay, and they were all supposed to equal 20,000. Okay, to note that the last payment out was at the start of the last month. Okay, so or the end of the 24th, or year rather, these are years, the end of the 24th year, so we use 24 as the last one, and our SN or our S25, because they were yearly, added up also to the total fund of the 358,000. Okay, so have a review over that yourselves. And finally, part E, I'm going to ask you to try this. Okay, if Padraig wants waits for 10 years before starting his pension investments, how much will he have to pay each month in order to generate the same pension fund? So the calculations here are pretty much the same as the last part of part D. The difference being that now he's making repayments for 30 years, not 40. So he will have to pay in over 360 months instead of 480. Okay, so your N will be 360. Okay, and you have to find P. So take some time to do that, and I'm going to give you the answer below, but see can you reach it yourself. €618.35. Best of luck.